Good morning, guys. So we're going to be graphing radical functions. So before we start, let's review the quatrains of our coordinate plane. So we have quatrain 1, quatrain 2, 3, and 4. So we know for 1, our x and y values are going to be positive and positive. For 2, it's going to be negative and positive. For 3, it's going to be negative and negative. And for 4, it's going to be positive and negative. So what this is going to help us with is when we have our function, it'll help us determine which quatrain our graph is going towards or which one it's in. So let's start with our parent function, y equals square root of x. And it's going to look like this. I'm going to write another function. So I'm going to write y equals negative square root of x. So we can compare how our knowledge of the quatrains can help us. Okay, so if you look at these points or the signs of these areas, you can determine where your graph is going. So for the first one, we see it's positive and positive. And for this one, we see it's negative and positive. And so what this means is our y value is negative and our x value is positive. So you can see that this goes over here and this goes over here. Meanwhile, over here, they'll just be positive. They'll both be positive. So we see our graph is going in, it's inside quatrain 1 because both our coordinates are positive. Meanwhile, for this one, it is going down here because our x is positive, our y is negative. And we can see over here that it's going to be in quatrain 4. So that helps with determining where our graph goes. Let's do a few more. We're going to do y equals square root of negative x. So we have positive and negative, so let's switch it. So we'll have negative, positive. And that means our graph will be in quatrain 2, which will give us this. And then let's do one more. It's going to be y equals negative square root of negative x. So when they're both negative, they're going to both end up in quatrain 3. So it'll be down here. Okay, so now let's label these reflections. Because when you change the sign of one of the coordinates, you have a reflection. So this one, nothing has been reflected. It's both positive. So this is our parent function. Okay, and now this one, if this is our parent function and this is what we got, we can see that it is reflecting across the x-axis. So if I were to fold this apart in half, we would land on that graph. So this is a reflection over the x-axis. And this one, if this is our parent function and this is what we got, we see that it's reflecting over the y-axis. So this is a reflection over the y-axis. And this bottom one, this is our parent function and this is what we got. It's a reflection over the origin. Over the origin. Okay, so you can see that when the x value changes, it's a reflection over the y-axis. So here we see it went from positive, which is our parent function, and it went to negative, positive. It's a reflection over the x. Meanwhile, over here, we're from positive to positive, negative. And so we're changing the y value, and that means a reflection over the x. And here, you change both, so it's a reflection over the origin, which you can think of as reflecting over the x and then over the y, or reflecting over the y and then over the x. Same thing. Okay, now what if I added a number here, added or subtracted a number next to our, for the first one we use our parent function. So next to our parent function, let's do plus 2. What this does is, so it's, let's draw our parent function first. What this does is it moves our graph up 2 points. So everything is shifted up 2 points. Okay, so we have this point as 0, 0, and it's shifting up, so you have 0, 1, and then 0, 2. 1 and then 2. Okay, so this, when you have that number added, it is the y-intercept. So if this was minus 2, instead, our function would move down 2 points. All our points would move, or all our points would shift down 2 points, and we'd have, it would be down here. Okay, so this is a transformation. For plus 2, it's transforming down 2 units. For minus 2, it's up 2 units, and for minus 2, it's moving down 2 units. Okay, so what if we have something inside our square root? So what if it was y equals x minus 2? Let's start with our parent function again. Okay, so minus 2 moves or transforms our function over 2 units to the right. And the reason why is because if you take this inside, set, and you solve for x, or you find what makes x 0, so you set it to 0, you get x equals 2, so that moves our graph over 2 points, and this is along our x-axis. And if I had square root of x plus 2, that would move everything to the left 2 units. It doesn't reflect it, it keeps it the same. It doesn't stretch or flatten it, it just moves our entire graph along the x-axis. So we know it moves to the left because if you set x plus 2 to 0, you're going to get x equals minus 2, which means going to the left. So that's a little review. Okay, now let's do one where our slope changes. So let's do y equals let's do y equals 3 square root of x. So what this means is we're going to start with a parent function, but our parent function is going to be vertically stretched. It's going to experience a vertical stretch because when your slope, which is m, is greater than 1, your graph is going to, if it's less than 1, your graph is going to flatten. But if it is greater than 1, it's going to stretch. Yeah. Okay, so usually we have these points 0, 0, 1, 1, 4, 2, 9, 3. And so if we're stretching our graph, we need to multiply. If it's stretching our graph vertically, which in this case we are, we're going to multiply our y values by 3 because our slope is 3. So when we do that, this is what we get. And so our new graph will be, we'll just follow these points. So these become our coordinates. So we have 0, 0, 1, 3. So these are our new points. Okay, so just gonna draw a rough sketch. It'll be something like that. And our points will be like along the graph. Okay, and let's do one where our graph flattens. So let's do x and y equals half the square root of x. So we have our parent function that I just draw as a visual. So I like to draw the same points. Okay. And now we're going to multiply our y values by half, or 1/2. So, and you get 0, half, 1, and 1.5. And so when you graph these points, so these are our new coordinate points, if you set it up kind of like this, taking this as your x and this as your y, your graph will look like this kind of. So that's how you graph the graph or the function when you have a slope, which is this number in front. And if we put it all together, and let's say we have a transformation, so we have +2, that'll move our graph up to, it's still flattened like that, it'll move it up to. And if we had -2, it would move it down 2, so down 2. And if this here we had +2, it would move to the left 2. And if we had -2, it'll move to the right 2. And we'll have that. So, yeah, okay. I think that is a good amount of examples for practicing with the square root of x. So now let's do some with the cube root of x. So say we have y equals cube root of x. So we have a graph. And basically, if we were to make this table again, it won't be the same as this, because these graphs apply for the square root of x, but now we have the cube root of x. And so it's gonna be different. So here we can see that when you plug 8 into x, the cube root of x is 3, because 2 times 2 times 2 is equal to 8. Oh wait, the cube root of 8 is 2, yeah. So that means the cube root of 27 is 3, because 3 times 3 times 3 is 27. So now that you have this, we can, there's no slope, so we'll just take these as our coordinates. So we can pretend these are all coordinates, or not pretend, these are our coordinates. When you graph it, you have something like this. So that's what you get for this. If I were to have a slope, so if I were to have a slope of 2, I would just multiply all my y values by 2, and that will vertically stretch my graph a little bit. But if I had half, like earlier, it'll make it like even, it'll flatten our graph. So that's how you do that. And so what I find kind of confusing is that if I were to have extra stuff, so if I had like +4 minus 2, when you make this graph, or not the graph, when you make this table to help you graph your function using the coordinate points, it's kind of confusing because you don't actually need all this stuff. Or even if I had a slope, let's add a slope. The only thing you need to look at is this part. So like over here, all we looked at was this part. That's how we came up came up with this table. So you only look at this part. So the degree and then the square root or the cube root or whatever root, and that's how you come up with the table. So we can see that both these tables are the same. So even though they have a different slope, you end up with the same table because you're starting off with the same parent function. Starting off the same parent function. And so even if you have a bunch of extra stuff like a slope and then like a y-intercept and then a transformation, all these transformations, you only look at this one part. So after you find these points, I find it easiest to draw the parent function, and then if it's -2, we can move it down, and if it has a transformation, you can move it left 4, and you can do all that stuff. Okay, let's do one more. Okay, let's do one more. For this one, let's include all the stuff that we just reviewed. And let's do y equals cube root of x minus 3 minus 5. Okay, so we're gonna look at this part. Cube root of x, so we can make that table of ours, x and y, and you have 1, 1, 8, 2, 27, 3, and there's no y-intercept, or not y-intercept, there's no slope, but we do have a transformation up or down 5 about the y-axis, and then to the right 3 on the x-axis. So we have this. So you can find the first point of your graph by looking at your transformations, and that is basically going to be kind of like your new origin. So when I look at this over here, we have 0, 0, which is, this is our new 0, 0, and then we have 1, 1. So what that means, so we see it's x is 1, so over 1, y is 1, so up 1. And then you have this point here. Now for the next one, we see x is over 8, y is up 2. So if I were to add some more points, so 5, that's not very accurate, but it's just a rough sketch. So yeah, 1, 2, 3, oh wait, start at your new origin and you count 1, 2, 3, 4, 5, 6, 7, 8, and then you have y2, so you go up 2, 1, 2, and you have this point. Okay, so 27, 3, yeah, so we have this, we have the right side of our graph. What we can do now is look at the degree. So we have a degree of 3. So what 3 means is that our graph is gonna keep going. So you have 3, 5, 7. Your graph is gonna continue. So it's gonna be a continuous graph. You have arrows at the end. But if it's square root, or you see a 4, a 6, or 8, your graph is gonna stop. So it's gonna, it's gonna go and it's gonna stop. So in this case, it's going to keep going, but we only have the right side of the graph. But we can graph the other side because we know this is our origin, and we know that it's just going to be the same side on the left. And so if it went earlier, if it went to the right one and up 1, now it can go down 1 and to the left 1. So it's just the opposite. And if it went to the right 8 and went up 2, now it's going to go down 2 and go to left 8. So it's almost like you're just making them negative. And then you're going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And so your graph will be something like this. And you'll just have arrows at the end because it's going to be continuous. Okay. So now let's do another one. Y equals -3 cube root of x plus 1 plus 3. So looking at this part, we see x squared. So we can write those we can write those points. We can write our coordinates 0, 0, 1, 1, 4, 2, 9, 3. And it has a slope of -3. So we're just going to multiply our y by -3. So this is still a vertical stretch. Only difference is instead of going from this up here, it's going to go down here since it's negative. So it's going to do the opposite. Okay, so we're going to get 0, -3, -6, -9. Okay, so before we start, let's find our new origin, which can be found by looking at this number and this number. So y-intercept plus 3. Okay. Oh, let's not plot that yet. And then plus 1, which means -1, means to the left one. So there we go. That's 1. Okay, so if I were to graph this, let's go ahead and use our new origin. So this is like our 0, 0. For 1, -3, that just means you're going to go to the right one and down 3. You're going to put the origin. For 4, -6, that means you go to the right 4, down 6. So you start from here, 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. And then we have -9, -9. So starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like that. So you have a graph that stops. So if the problem asks for the domain and range, so domain, how I like to remember it is, we're always taught that x is the independent and y is the dependent. So it's kind of like x is the main character. So x is our domain. See, we have main in there. So looking at our x-axis, where do our points go? Well, they go from -3 to infinity. Wait, hold on. That's not our domain. Our domain is -1 to infinity. Oh, right. So we end here, but our points are going to keep going. We're just not sure. Or we're just too lazy to keep going and make bigger numbers. So yeah, and then up here, our domain would be all real numbers, which is also like this. That's all real numbers. And our range, which is our y-intercept, which is the points corresponding to our y in this case. Even though our thing is like kind of not that steep, it'll still keep going. So our range would be also -infinity to infinity, which is also all real numbers. And down here, what is our range? Our range is -infinity to 3. That is it. Yeah. So you have infinity because our graph is going to keep going till who knows when, but it's not going to get any higher than 3. So yeah, that's it. Bye, guys.